Hey everyone, and welcome. Today, we are diving deep into a concept that's absolutely core to professional machine learning, data and model lineage. You can think of it as the ultimate audit trail for your AI. Honestly, it's what separates a fragile little experiment from a rock-solid production-grade system. So let me paint a picture for you. Your main production model, its performance just suddenly tanks. Is it bad data? A feature that went haywire? Some subtle bug in the training code? Without a clear history, you're completely lost. It's just a chaotic guessing game. And this, right here, is the exact nightmare that Lineage is built to solve. So here's our plan. We're going to break it all down. First, we'll define what Lineage actually is. Then, we'll see why it's such a cornerstone of MLOps. After that, we'll get our hands dirty with a practical implementation using MLflow. And finally, we'll wrap up with some key challenges and best practices. Sound good? Let's jump in. Okay, first things first. What in the world is Lineage? Well, you can think of it as the foundational blueprint for any ML system you're trying to build reliably. At its heart, data and model lineage is all about tracking the entire life cycle of your data and your models. It really is that detailed audit trail. It records everything, where your data came from, every single change made to it, how it was used to train a model, and finally, where that model ended up in production. It's the model's entire life story, from raw data all the way to a prediction. And that story really has 4 key chapters. First up, data origin. We need to know exactly where the data came from. Was it a database, an API, a bunch of files? Second, data transformations. We've got to record every single processing step, all the cleaning, the feature engineering, the whole shebang. Third, model training. This is where we capture the specifics, the exact data version, the hyperparameters, the code itself. And finally, number 4, model deployment. Which version is running where? You put these 4 together and you have a complete, totally unambiguous history of everything that happened. Okay, so that's the what. But why? Why is Lineage so absolutely fundamental to MLOps? Let's really get into why this is the bedrock of any AI system that's ready for the real world. The first and maybe the most immediate win you get is way faster debugging. I mean, when a model fails, Lineage is like a direct map that lets you trace the problem right back to its source. No more guesswork. You can see in an instant if it was a change in the source data, a bug in a transformation script, or something else. It turns what could be hours of frantic searching into a quick, focused investigation. Next up, and this is a big one, governance and compliance. In a lot of industries, you are legally required to prove where your data came from and exactly how you used it. Think about regulations like GDPR. They demand this stuff. Lineage gives you that transparent, auditable record that's not just critical for legal reasons, but also for making sure your AI practices are responsible and ethical. Then there's reproducibility. Let's be real. If you can't reliably reproduce your results, you don't really have a scientific process, do you? You just have a happy accident. Lineage gives you the precise blueprint, the exact code, the exact data, the exact parameters to recreate any experiment or any model perfectly. And that's just non-negotiable for any serious engineering work. And this leads to one of the most powerful benefits of all, proactive impact analysis. Imagine, before you change a data source or a feature script, Lineage gives you a map of everything that depends on it downstream. You can see exactly which models will be affected. This lets you prevent those unexpected failures before they ever even happen. It's all about being proactive instead of just being reactive. So, just to sum that up, these benefits really power the main use cases. Lineage helps you discover and actually understand your data, perform that proactive impact analysis we just talked about, streamline all that governance stuff, and even find bottlenecks to make your whole pipeline faster. It's an incredibly useful tool. All right, now for the fun part. Let's move from all the what and why to the how. We're going to walk through a real, concrete example from the MLOps Python package, which uses MLflow to make this whole process pretty seamless. So the way this is implemented uses a really smart, object-oriented pattern. It starts with something called an abstract class, in this case, a reader. Now, especially for those of you coming from a pure data science background into more of an engineering role, think of an abstract class like a contract. It defines methods that must be included by any other class that uses it, which forces a really solid structure on your code. And what's so brilliant about this is that the design itself forces you to have a lineage method. Just think about that for a second. You literally can't create a class to read data in the system without also defining how to track its origin. It builds best practices right into the code. Lineage isn't an afterthought. It's a requirement.
So, how does this contract actually get fulfilled? Well, with a concrete class, like this Parquet reader. This class inherits from our abstract reader, and it provides the real code for both reading a Parquet file and, most importantly, for implementing that required lineage method. And this is where the magic really happens. Inside that lineage method, one single function call, MLflow.data from pandas, does all the heavy lifting. It takes the data and automatically creates a special MLflow dataset object. This thing captures the schema, the source path, all that critical metadata. This object is what gets logged to MLflow, and that's what creates the link in our audit trail. It's awesome. And the payoff for doing this is fantastic. When you log this dataset to an MLflow run, the user interface automatically builds this cool interactive graph. You can literally click through and visually explore the entire journey of your data, from its source through any transformations and all the way into the final model. It just makes the whole history tangible and super easy to understand. Of course, building a truly robust lineage system, it's not always a walk in the park. So let's wrap up by being realistic and talking about the challenges you might face and some key best practices for really getting it right. First up, the challenges. Trying to integrate Lineage across a whole bunch of different tools can get complex fast. You also have to figure out the right level of granularity. Too little detail, and it's useless. Too much, and it's just noise. You also really want to minimize any manual work. And of course, make sure the whole thing can scale as your projects get bigger. All this stuff requires some careful planning upfront. But here's how you can build a truly world-class system. Don't just log the original source. Log your key transformation steps along the way. Integrate with a tool like DVC to actually version your datasets for total reproducibility. Make sure you document the why behind your feature engineering, not just the what. And finally, look at standards like Open Lineage to help you connect all the dots across your entire data ecosystem. So at the end of the day, Lineage isn't just some technical tool for debugging. It's the narrative. It's the complete record of your model's entire life. Its birth, its education, its whole career. So the real question to leave you with is this. Once you can finally track its full history, what is the complete story that your model is telling you? Thanks for tuning in.